So next thing we're looking at is this here. I know I skipped a page or two with increasing, decreasing, but we're looking at these here. So turn one page. Yep. Yeah. Increasing, decreasing is important. It's nice to know, but in the grand scheme of things, neither here nor there. Because increasing says that as we go from the left side of the graph to the right, the function's going up. Decreasing says as we read from left to right, the function's graph is going down. And we define it on the x values. Now this here is the third type of parabolas, quadratic functions we're going to look at. Now, this here, I call it x-intercept form. X-intercept form. Well, the reason I call it x-intercept form is because the two main values that they give us, p and q, are the x values of the x-intercepts. X-intercept form, exactly what it's named. Because when we plug p and q into the function, we'll get a y value of 0. And those are our x-intercepts. P comma 0, q comma 0. Axis of symmetry is given to us by the equation x is equal to p plus q over 2. Interestingly enough, the vertex is the point p plus q over 2, comma f of p plus q over 2. So the vertex is the point p plus q over 2, comma f of p plus q over 2. And just like what we did in yesterday, or what we did yesterday with standard form, negative b over 2a, comma f of negative b over 2a, we find out what that value is, plug it back into the function. So, when we look at this first problem here, it'll be good to start off with knowing what the values of A, P, and Q are. And for us here, the value of A is negative 2. The value of P, negative 3. Because it's x minus P, and the only way to go from x minus P to x plus Q is if the value, or x minus P to x plus 3, is if the value of P is negative 3. Because our negative and negative would give us positive. Value of Q is 1. Vertex. Axis of symmetry. So, there's two main calculations we have to do. One of them is p plus q over 2. The other is going to be f of p plus q over 2. But we could do one of these pieces, find the x-intercepts before we do anything else. Because the y value at the x-intercept is always going to be 0. Because the x-intercepts where it crosses the x-axis. The y value at the x-axis is always 0. So we know that the y value at our x-intercepts is going to be 0 and 0. One of them is going to be p, comma 0. And our value of p is negative 3. So we have one of the x-intercepts at negative 3, 0. The other is going to be q, comma 0. And our value of q is, we have the two x-intercepts, negative 3, comma 0, and 1, comma 0. We actually know the solutions for this here. It's negative 3 and 1. Because when we find the solutions, we're trying to find out what value of x will make the y value be 0, negative 3 and 1. Okay, now we actually have to do some calculations. So our p plus q over 2. Well, we said the value of p is negative 3, and the value of q is 1. Now at this point here, we can plug that into the calculator and it can do it for us. Or we can actually add them. Negative 3 plus 1 is negative 2. And negative 2 divided by 2 is negative 1. So we'll plug it into the two spots where p plus q over 2 is. The x value of the vertex and what our axis of symmetry x is equal to. So x equals negative 1, and we have negative 1 in the x spot of the vertex. Now the other part is to find the y value. So we have f of p plus q over 2, or f of negative 1, which is going to be negative 2 times negative 1 plus 3 times negative 1 minus we get this here. Now we could put parentheses around the negative 1. I want to be erasing that. So we could say negative 1 plus 3 and negative 1 minus 1. We could put the parentheses around it just to make sure. Don't necessarily need them. So if you put them, you're going to get the same answer. If you don't put them in this case, you will still get the same answer. And again, at this point, we could type this whole thing in just like we see it here, and it would give us an answer. If we do this by hand, negative 1 plus 3 is 2. Negative 1 minus 1 is negative 2. Now we just need to multiply. Negative 2 times 2 is negative 4. Negative 4 times negative 2 is going to be positive 8. Because our negative and negative make a positive. 4 times 2 is 8. So that tells us the y value of the vertex is 8. And that's all we're looking for. Now we'll go on and graph this one. I'll go on and graph it here. Now we know the vertex is the point negative 1, 8. We get this point. The x-intercepts are negative 3, 0, 1, 0. Our axis of symmetry would cut it in half. And we get something that looks like this here. Gives us a rough idea of what it looks like. Might be a little steeper, might be a little narrow. It might be a little wider, a little steeper, but we get a good estimate of what this is. Because our other 2 points should probably be about here and here, if I had to take a guess. But we get an idea of what the graph should look like. Questions on this here? We ready for the next one? So looking at this equation, comparing it to the general form, our value of A is 1/3. Our value of P, 4. Would it be positive or negative? Positive, and Q is negative 2. And now we know the y value of the x-intercept has to be 0. because we have p comma 0 and q comma 0. Vertex is p plus q over 2 comma f of p plus q over 2. What are our x-intercepts? What number would go in place of p? What would go in place of q? So our two x-intercepts are 4, 0, negative 2, 0, yes? Yeah. Could I have flipped the values of p and q? Could I have said that q is 4 and p is negative 1? So what would it change if I did? So if I switched them and I said p is negative 2 and q is 4, our x-intercepts would be what? Negative 2 comma 0 and 4 comma 0, yes? Did that change anything? No, we still have the same two intercepts, yes, they're in a different order. So x-intercepts, it doesn't change anything. Okay. Because we didn't really do any calculations, we just stuck those in, yes? Okay. Let's leave it the same. P plus q over 2. So it'd be 4 plus negative 2 over 2, yes? 4 plus negative 2 is 2. 2 divided by 2 is? Okay. We feel comfortable with that there. All right, I'm going to switch p and q. That means that's not 4 and that's not negative 2. That means the first one's negative 2 and the second one is 4, yes? Okay, what's negative 2 plus 4? 2. 2 divided by 2 is? Did it make a difference what p and q are? No, we still got the same value here. We still got the same x-intercepts. Axis symmetry is still 1. Vertex is x value still 1. These two here are being multiplied, yes? When we multiply two terms, two numbers together, does order matter? 4 times 2 is still the same as 2 times 4, yes? I always get it mixed up. I believe it's the commutative property of multiplication. We can multiply any two things in any order and still get the same number. That's all we're doing here. 4 and negative 2. I have to pick one of them as p and the other as q. Now the last thing we have to do is plug it in, yes? So we have negative 1/3 times 1 plus 4, not 1 plus 4, what am I thinking? 1 minus 4 times 1 plus 2, yes? This is actually kind of nice. Looking at there, you'd probably disagree because you're saying we have a 1/3 multiplication, yes? Well, what's 1 minus 4? 1 plus 2. Negative 1/3 times negative 3. Well, the negative and negative make a positive. So what's 1/3 times 3? 1. 1 times 3? That's why I said it was nice. Because our 1/3 and 3, 1/3 that negative 3, got rid of the fraction. So it made it easier to work with. We could have also typed that whole thing into the calculator. I would have done it in the 30xs. Negative 1/3 times negative 3 times 3 would give us our answer, even if we were saying 4 and 5. Even if they didn't divide by 3, the calculator will still give us the answer. So if you don't feel comfortable, especially with negative negatives, negative 1/3 times negative 1 plus 4 times negative 1 minus, well, it would help if I get my signs right. because it's 1 minus 4, 1 plus 2. Still give us the answer. Questions on those here? A in this case is -1. P, Q, -5. So my x-intercepts are -1, 0, -5, 0. We just plug P and Q in. Vertex. I have to calculate what? P plus Q over so P plus Q over 2. -1 plus -5 over 2. I think by this point y'all already figured out is -3, yes? Now we got to plug it in. -3 plus 1 times -3 plus 5. -3 plus 1 is -2. -3 plus 5 is 2. And we get the y value of 4. We feel comfortable with this here? Do we need to see another example of one of these? Nope. Because if you did this one, vertex would have been 4, -1, axis symmetry, x equals 4. Intercepts are going to be the points 6, 0, and 2, 0. 6 plus 2 is 8. 8 divided by 2 would be 4. 4 minus 6 is going to be -2. 4 minus 2 is 2. So 2 times -2 would be -4. -4 times 1/4 is -1. And we have our other parts. And I believe that's the last problem, isn't it? So instead of giving y'all a sheet on the back, you're welcome. Printed off a worksheet. So 1 through 4, vertex, axis of symmetry, that's it. Find the vertex, find the axis of symmetry. 5 through 8, use the axis of symmetry to match the equation to its graph. A, B, C, D. 9 through 12, find the vertex and axis of symmetry. 13 through 15, find the vertex, axis of symmetry, and the x-intercepts. And that's it.